Hello everyone. In this session, we are going to learn applications of differential equation. So, the first concept is Newton's law of cooling. So, Newton's law of cooling statement: the rate of change of temperature of a body is proportional to the difference between the temperature of the body and that of the surrounding medium. This is the statement of Newton's law of cooling. The statement is the rate of change of temperature of a body which is proportional to the difference between the temperature of the body and that of the surrounding medium, or is same as dt divided by d small t, which is proportional to capital T minus T2, or dt by d small t is equal to minus k times of T minus T2. This is the expression for differential equation expression for Newton's law of cooling. So, here this is the symbolical representation of statement rate of change of temperature with respect to time which is proportional to difference between the temperature of the body and surrounding medium. So, here capital T denotes temperature of the body at any time. So, T2 denotes the surrounding temperature or air temperature. This is the expression for differential equation expression for Newton's law of cooling, where here in this expression, so T, capital T denotes temperature of the body at any time. So, K is proportional constant. Proportionality constant. So, T2 is the surrounding temperature or air temperature. Here negative sign indicates cooling of the body with increases of the time. And solving this equation, solving the differential equation dt divided by d small t is equal to minus k times of T minus T2. So, using linear equation concept we get the expression for temperature function. Therefore, temperature function T equals, so T2 plus T1 minus T2 into e power minus kt. After solving this equation by using linear equation concept, we get the solution temperature function, here dependent variable T, therefore temperature function solution in terms of T, capital T equals T2 plus T1 minus T2 into e power minus kt. Here T, already we know that capital T stands for temperature of the body at any time. So, T2 we know that surrounding temperature or air temperature. T1 is the initial temperature of the body. T1 stands initial temperature of the body. K is proportionality constant, T is time. Using this expression we can find out the temperature of an element after some time. Now, I am going to solve the problems in Newton's law of cooling. The first one question is, a body in air at 25 degrees Celsius cools from 100 degrees Celsius to 75 degrees Celsius in 1 minute. So, surrounding temperature is 25 degrees Celsius and a particular an element initially is 100 degrees Celsius, it reduces to 75 degrees Celsius, it takes 1 minute time. Then using given data, find the temperature of the body at the end of 3 minutes. This is the question. Means a particular an element kept in one room. So, the temperature of room is 25 degrees Celsius. That element cools 100 degree to 75 degree. It takes 1 minute time. Then using given data, find the temperature of an element at the end of 3 minutes. This is the question. So, solution is, according to the Newton law of cooling, the temperature function at any time t is given by, so capital T is equal to T2 plus T1 minus T2 into e power minus kT. This is temperature function formula. In the next line, write on the given data. Given data, so T2 air temperature 25 degrees Celsius, T2 is equal to 25 degrees Celsius. So, T1 initial temperature of the body 100 degrees Celsius. When time is equal to 0, initial temperature of the body is equal to 100 degrees Celsius. Then after some time 75 degrees Celsius, 100 to 75 degree means capital T is equal to 75 degrees Celsius when T is equal to 1 minute. At the end of 1 minute, the body cools 100 to 75 degree Celsius, that is capital T is equal to 75 degree. So, in this problem, we have to find out capital T when T is equal to 3 minutes. Before finding capital T value, means temperature of body, first find out the proportionality constant. Proportionality constant means first find out the K value. So, therefore, using given data, in the equation temperature function or equation 1 we get, so capital T 75 is equal to T2 is nothing but 25 plus T1 initial temperature 100 minus T2 is nothing but 25 into e power minus k constant into T is equal to 1 minute, T equals 1 minute, or 75 equals 25 plus 75 into e power minus k, or is same as 75 minus 25 is equal to 75 into e power minus k, or 75 minus 25 is nothing but 50 is equal to 75 into e power minus k, or is 50 by 75 is equal to e power minus k, or it can be written in the form of e power k is equal to 75 by 50. Therefore, 25 2s are 25 3s are, e power k is equal to 3 by 2, which is nothing but 1.5. E power k equals 1.5. In the next step, take log on both sides, means natural logarithmic function on both sides. Therefore, log of with base e power k is equal to log of 1.5 with base e, or is same as here I am going to use logarithmic function property k into log e with base e is equal to log base e 1.5. But we know that log of base e with e is equal to value, log e with base e is equal to value, this is equal to 1. This value of log e with base e is equal to 1. Therefore, k equals log e of 1.5. So, log e of 1.5 or k equals, so log of 1.5 value is nothing but 0.4055. By using calculator, we can find out the value of log of 1.5. Therefore, k equals 0.4055. This is proportionality constant value, k value. Using k and given data, find out the temperature of a body at the end of 3 minutes. In the continuation, after finding proportionality constant K value, using K and remaining data, find out the temperature at the end of 3 minutes. Therefore, so using again temperature function formula, capital T equals T2 plus T1 minus T2 into e power minus Kt. In this expression, we have to find capital T when T equals 3 minutes. Here we have to find out capital T when T is equal to 3. In the next step, capital T is equal to T2 is the air temperature 25 degree plus T1 is the initial temperature 100 degree minus T2 is the room temperature 25 degree into e power minus K. K is the proportionality constant, K value 0.4055 into T is equal to 3. Okay. In the next line, T equals 25 plus 100 minus 25 is nothing but 75 into e power multiplication of these two 0.4055 into 3 is nothing but 1.2165. By using calculator, we can multiply the term 3 into minus 0.4055, we get minus 1.2165. Finally, after multiplication of these two terms, 75 into e power minus 1.2165 plus 25, we get 47.22 degrees Celsius. This is the temperature of a body at the end of 3 minutes. Thus, we conclude that the temperature of a body at the end of 3 minutes is 47.22 degree Celsius. Okay. Now, we are going to solve the second problem in Newton's law of cooling. So, second question is, if the temperature of the air is 30 degrees Celsius. So, air temperature or room temperature of one particular metal ball is 30 degrees Celsius, and a metal ball cools from 100 degrees Celsius to 70 degrees Celsius in 15 minutes. Initially, the temperature of metal ball is 100 degrees Celsius. It cools from 100 to 70 degrees Celsius. It takes 15 minutes time. Okay. Then find how long will it take for the metal ball to reach a temperature of 40 degrees Celsius. This is the second one question. In this problem, we have to find out time T when metal ball reaches to a temperature of 40 degrees Celsius. So, first, according to the Newton's law of cooling, the temperature function at any time T is given by, in the solution, temperature function T equals T2 plus T1 minus T2 into e power minus Kt. This is the temperature function, but time being it denoted by equation 1. So, according to the Newton's law of cooling, temperature function T equals T2 plus T1 minus T2 into e power minus Kt. So, for further continuation, write on the given data. So, given data T2 initial temperature, surrounding temperature of metal ball is 30 degrees Celsius. Initial temperature is 100 degrees Celsius. T1 is equal to 100 degrees Celsius is the initial temperature of the metal ball, and capital T is equal to temperature of the metal ball 70 degrees Celsius when T equals 15 minutes. T equals 15 minutes. Using given data, first find out the proportionality constant. Using K and given data, find out the time when metal ball reaches to a temperature of 40 degrees Celsius. Here temperature T equals 70 is equal to T2 is equal to 30 plus T1 100 minus 30 into e power K into T is equal to 15 minutes. When T equals 15, temperature of a body is equal to 70 degrees Celsius. Therefore, 70 is equal to 30 plus 100 minus 30. So, 100 minus 30 is nothing but 70 into e power minus 15k, or 70 minus 30 is equal to 70 into e power minus 15k, or is same as 40. Here LHS 70 minus 30 is nothing but 40 is equal to 70 into e power minus 15k. 0 0 get cancel, or 4 by 7 is equal to e power minus 15k, or is same as e power plus 15k equals 7 by 4. 7 by 4 is same as 1.75, or is same as e power 15k equals 1.75. In the next step, taking log on both sides, therefore log of e power 15k is equal to log of 1.75, or is same as 15k into log e is equal to log of 1.75. So, for further continuation, 15k into log e value is equal to 1, and after the step 15k is equal to is same as 15k is equal to log of 1.75, or is same as k is equal to log of 1.75 divided by 15, or is same as finally by using calculator log of 1.75 divided by 15 is same as 0.0373. This is the proportionality constant value. So, you now using given data and proportionality constant k value, find out the time t when metal ball reaches to a temperature of 40 degree Celsius. Therefore, using again by using temperature function formula, capital T is equal to, capital T means 40 degree Celsius is equal to T2. T2 is nothing but temperature, air temperature 30 plus T1 initial temperature of a metal ball. So, initial temperature of a metal ball is 100 degrees Celsius minus air temperature 30 into e power minus k. K is nothing but proportionality constant 0.0373 into T. So, we have to find out time small t when metal ball reaches to a temperature of 40 degrees Celsius, or is same as 40 is equal to 30 plus 100 minus 30 is nothing but 70 into e power minus 0.0373 into t, or 40 minus 30 equals 70 times of e power minus 0.0373 into t. 40 minus 30 is nothing but 10. 10 is equal to 70 into e power minus 0.0373 into t. Here 1 0 get cancelled, or is same as 1 is equal to 7 into e power minus 0.0373 into t, or 1 by 7 is equal to e power minus 0.0373 into t, or it can be written in the form of e power 0.0373 t is equal to 7 by, or in this in the next step taking log on both sides, therefore log of e power 0.0373 into t is equal to log of 7, or again here I am going to use logarithmic function property. Log of e power m is nothing but 0.0373 into t into log e is equal to log 7. So, this value becomes 1 is equal to 1. Log e with base e value is equal to 1. Therefore, 0.0373 t is equal to log base e with 7, or t is equal to log 7 with base e divided by 0.0373 373. After calculation by using calculator, we get T equals 52.17 or approximately 52.20 minutes. Finally, T equals 52.2 minutes. So, 52.2 minutes time will take the metal ball reaches to a temperature of 40 degrees Celsius. Thus, we conclude that it will take 52.2 minutes for the metal ball reaches to a temperature of 40 degrees Celsius. Thank you.